Telescope was more than a machine. It was a promise to look deeper, further, and with more clarity than ever before. Its images became iconic, breathtaking glimpses of the universe once hidden in darkness. But this is not just a story of discovery. This is a tribute to 35 years of wonder. From 1990 to 2025, I've selected one image for each year. Some are scientific highlights, others are iconic images, while the rest are lesser known, yet still equally as stunning. Each image you are about to view reminds us why Hubble is such an incredible human achievement. This is a celebration of light, time, and a telescope that changed how we see the cosmos forever. You're watching V101 Space. My name's Rob, and if you enjoy diving into the wonders of space, don't forget to subscribe for much more to come. The image that started it all. This was Hubble's first light, its very first look into the universe from low Earth orbit. Released in May 1990, it was more than a test shot. It was proof that humanity had finally stepped beyond the blur of Earth's atmosphere. On the right, the raw clarity of Hubble's wide field. On the left, the same region of sky taken from the ground in Chile. The difference is stark. For the first time, we weren't looking through the sky, we were looking past it. But not everything was perfect. Scientists soon noticed a problem. A flaw in Hubble's primary mirror was subtly blurring its vision. The images were better than Earth's, yes, but not what they were meant to be. It was a quiet flaw that would soon set the stage for one of the most daring repair missions in space history. In 1991, Hubble turned its focus to Jupiter, offering an early look at the gas giant with a clarity not seen since the Voyager probes passed by in the late 1970s. In 1992, this image helped confirm the presence of something extraordinary at the heart of Galaxy M87, a massive black hole. In June 1993, Hubble brought the universe into sharper focus, not just in detail, but in distance. Astronomers announced a major breakthrough, a precise measurement to Galaxy M81, placing it at 11 million light-years away. Only with accurate distances could scientists begin to better understand how fast the universe is expanding and how old it really is. At the time, estimates for the age of the universe ranged from 10 billion to 20 billion years. Thanks to Hubble, the window was beginning to narrow. The universe was finally starting to reveal its timeline. Now we know that the universe is approximately 13.8 billion years old. By the end of 1993, Hubble's vision was about to change forever. Aboard the space shuttle Endeavour, 7 astronauts carried out the telescope's first servicing mission, a bold, high-stakes repair in low Earth orbit. They installed a new camera, the Wide Field and Planetary Camera 2, equipped with corrective optics. Alongside it, a revolutionary system called CoStar gave Hubble's existing instruments the clarity they were meant to have. When the mission ended, the universe snapped into focus. Hubble's true potential had finally been unleashed. In July 1994, Hubble witnessed a cosmic catastrophe, a planetary drama unfolding across the face of Jupiter. This image reveals 8 dark scars etched into the gas giant's atmosphere, the aftermath of comet Shoemaker-Levy 9, which had shattered into 21 fragments during a close pass-by of Jupiter 2 years earlier. Now, those fragments were slamming into the planet at over 200,000 kilometers per hour, each impact leaving a mark larger than Earth itself. And for the first time, thanks to Hubble's newly corrected optics, we saw it all in stunning clarity. No longer held back by blurred vision, Hubble captured this rare event in exquisite detail. Not just a glimpse, but a front row seat to our solar system in motion. It was a moment that reminded us the universe is not still. It is dynamic, violent, and alive. In 1995, Hubble released a sweeping, full-colour mosaic of the Orion Nebula, one of the most detailed and expansive views it had ever produced. In 1996, the Hubble Deep Field was unveiled, capturing hundreds of previously unseen galaxies in what was, at the time, the deepest view into the universe ever captured. In early 1997, Hubble's eyes were opened wider than ever before. During its second servicing mission, astronauts installed a powerful new instrument, the near-infrared camera and multi-object spectrometer. This wasn't just an upgrade, it was an evolution. For the first time, Hubble could peer into the cosmos in infrared, a wavelength invisible to the human eye, but essential for revealing what lies behind thick clouds of dust and gas. In 1998, Hubble revealed a chaotic scene of stellar birth in a nearby active galaxy, a turbulent mix of dust, gas, and young stars. By the end of 1999, Hubble had gone silent. A series of gyroscope failures had forced the telescope into safe mode, leaving it adrift, still in orbit but unable to see. What followed was no ordinary mission, it was a rescue. Aboard the Space Shuttle Discovery, 7 astronauts launched into space, a critical effort to bring Hubble back to life. Over the course of 8 days, they replaced all 6 of the telescope's gyroscopes, installed a faster onboard computer, and performed essential upgrades to its systems. When Discovery departed, Hubble was restored, not only repaired, but revitalized. Once again, it opened its eye to the universe, and once again, it began to see even clearer. In 2000, light and shadow came together in Hubble's striking view of the Carina Nebula, where columns of dust hinted at stars in formation. In 2001, the Horsehead Nebula was imaged in remarkable detail, its distinctive shape standing out against a glowing backdrop of gas. In 2002, Hubble received a powerful new eye, the Advanced Camera for Surveys, or ACS. Installed during the telescope's 4th servicing mission, ACS was designed to do one thing better than ever before: see deeper, with more detail across a wider field of view. The first images taken with the new camera were nothing short of extraordinary. The Cone Nebula rising like a cosmic tower from flowing gas. The Mice Galaxies locked in a gravitational dance. And the Tadpole Galaxy with its trailing tail of stars, each one a testament to the camera's unmatched clarity. In 2003, one of the largest and most intricate images Hubble had produced, the Helix Nebula, appeared almost like a cosmic eye staring back from deep space. In 2004, Hubble captured a rare phenomenon: light echoes radiating from a distant stellar outburst, illuminating space like ripples in a pond. In 2005, a remarkably detailed image of the Crab Nebula revealed a tangle of glowing filaments and swirling remnants of a long-past supernova. In 2006, the vibrant star cluster Pisces 24 resolved with brilliant clarity, showcasing dozens of massive young stars. In 2007, Hubble returned to the Carina Nebula, capturing new layers of structure and star formation with even greater depth. In early 2008, Hubble helped map the invisible. This image of the supercluster Abell 901/902, a colossal gathering of hundreds of galaxies, reveals something extraordinary: the unseen structure that holds the universe together. The magenta-tinted clumps aren't stars or gas. They represent dark matter, an invisible substance that makes up most of the universe's mass, yet cannot be seen directly. Hubble can't photograph dark matter, but it can trace its presence. Astronomers used a technique called weak gravitational lensing, analysing how the light from over 60,000 galaxies behind the cluster was subtly warped by the mass in front of it. The result is a ghostly map, a cosmic fingerprint, showing that these galaxies don't simply float in space, they lie embedded within vast, hidden webs of dark matter. It was a haunting reminder that what we see in the universe is only a fraction of what's truly there. In 2009, a rare quadruple transit of Saturn's moons was captured as 4 satellites crossed in front of the gas giant in a perfectly timed sequence. Then, Hubble was given one last visit, a final chance to renew its strength and extend its legacy. After initial cancellation, the mission was eventually reinstated. Aboard the space shuttle Atlantis, astronauts embarked on a daring and complex journey to upgrade and preserve one of humanity's greatest scientific instruments. Over 5 spacewalks, they installed new instruments, repaired failing components, and gave Hubble the tools it needed to continue exploring deeper, clearer, and longer. It was Hubble's 5th and final servicing mission, a farewell not of endings, but of endurance. And because of it, Hubble will go on capturing the universe's wonders for years to come. In 2010, this delicate shell was captured, appearing to float serenely in the depths of space. But this apparent calm hides an inner turmoil. The gaseous envelope formed as the expanding blast wave and ejected material from a supernova tore through the nearby interstellar medium. The bubble is the invisible remnant of a powerful stellar explosion in the Large Magellanic Cloud, a small galaxy about 160,000 light-years from Earth. In 2011, a portrait of the flocculent spiral galaxy NGC 2841 showed a less structured but equally beautiful swirl of stars and dust. In May 2012, Hubble helped us look not into the past, but into the future. Astronomers announced that our home, the Milky Way, is on a collision course. Its destination? The Andromeda Galaxy. Though it now lies 2.5 million light-years away, Andromeda is falling towards us, drawn by the slow, inescapable pull of gravity. In roughly 4 billion years, the two galaxies will meet in a titanic head-on collision. This isn't the stuff of science fiction, it's cosmic inevitability. Stars will scatter, spiral arms will twist and merge, and over time, the two great galaxies will become one. Thanks to Hubble's precision, we no longer wonder if this will happen, we know when. In 2013, an infrared view of the Horsehead Nebula brought forward cooler, hidden features that have remained unseen in visible light. In 2014, Hubble peered into Abell 2744 and delivered its deepest image of a galaxy cluster, revealing some of the youngest and faintest galaxies ever detected. In 2015, the iconic Pillars of Creation were revisited with improved instruments, revealing new textures and features in this star-forming region. In March 2016, Hubble broke a barrier and looked farther into the past than ever before. Astronomers announced the discovery of GN-Z11, the most distant galaxy ever observed at the time. A brilliant infant galaxy seen as it was 13.4 billion years ago, just 400 million years after the Big Bang. To find it, Hubble had to push the limits of its sensitivity and precision, capturing ancient light stretched thin by the expansion of the universe. What we see isn't just a galaxy, it's a glimpse into the universe's first breath, a fragile, glowing ember from the dawn of time. With this single image, Hubble didn't just set a record, it connected us to the very beginning. In 2017, a dramatic scene of galactic collision was captured mid-process, illustrating how galaxies can merge and reshape one another over time. In 2018, this trio of images was unveiled, telling a quiet but powerful story, the transformation of Hubble's vision over 25 years. On the left, a blurry view of the spiral galaxy Messier 100, taken in 1993 with Hubble's original camera, a reminder of the flaw in its mirror that once blurred the stars. In the centre, the same galaxy seen in 1994, after astronomers installed corrective optics and a new camera during the first servicing mission. Suddenly, the universe came into focus. And on the right, the most recent image taken in 2018 with the Wide Field Camera 3, installed during Hubble's final servicing mission. 3 generations of images, 1 galaxy, a quarter-century of progress, and proof that even in space, vision can evolve. In 2019, by capturing a spiral galaxy almost edge-on, Hubble revealed its layered, 3-dimensional structure in vivid relief. In 2020, a delicate spiral pattern was observed in a distant galaxy, its arms appearing soft and feathered as they stretched outward from the core. In 2021, A.G. Carini was shown in spectacular detail, the luminous blue variable star surrounded by a glowing shell of gas shaped by powerful stellar winds. In 2022, Hubble reached across nearly all of time and found a single star. This ancient point of light, detected by Hubble, existed within the first billion years after the Big Bang. Its light has travelled 12.9 billion years to reach Earth. The previous record holder was nearly 4 billion years closer. This new discovery wasn't a deeper look, it was a leap across eons. No telescope has ever seen an individual star at such a distance. Yet Hubble, still pushing boundaries after more than 3 decades in space, did just that. A solitary beacon from the dawn of the universe, and a reminder that even the faintest light can survive the longest journey. In 2023, a spiral galaxy was highlighted amid a field of thousands, standing out as a graceful centerpiece within a vast cosmic crowd. In 2024, Hubble provided a nearly edge-on view of lenticular galaxy NGC 4753, revealing its complex shape and subtle spiral structures. More than 3 decades after its launch, in 2025, the Hubble Space Telescope is still at work, still capturing breathtaking images from the depths of space. Its mirrors have revealed newborn stars, ancient galaxies, and the invisible scaffolding of the cosmos. It has reshaped our understanding of time, light, and our place in the universe. And remarkably, it's not done yet. With careful management, Hubble is expected to continue observing until the mid-2030s. It began as an ambitious experiment, a telescope in space.